So we're now going to talk about the requester part of the world. This, of course, is the part that's making the requests to the various controllers to do various things. And we'll quickly go through how we set things up. We've talked about this before, so I'm not going to belabor this, but this is basically how you set the connection up with a connection initiator. And it starts by building an RSocket requester builder. Then you tell it what type of messages you want to send, which are going to be binary messages using the concise binary object representation CBOR protocol. We then go ahead and set up the encoders and decoders for this protocol, and we set up the authentication mechanism to make sure that we have the right credentials. We then go ahead and, because we are a requester, but we also have to be responding to the responder when it does the handshake to set the connection up. So we have to set up our connector, our acceptor strategy, and we also have to set up something that's going to do the connections if we don't succeed right away because the server may not, or the requester hasn't started, the responder hasn't started yet, sorry. And so these are basically plumbing issues to get everything all set up. We then set up the route we're going to talk to the server with, and we're going to pass over the metadata related to the credentials, like our login, name and password, and the type of the metadata request information. We then give the identity of the client or the requester to the responder so it can store it inside its database or its map. And then finally, we connect everything up, and now we are connected to the responder with a TCP connection. So data can start to flow. So not much different from what we covered before, so I didn't want to dwell on this very long. Let's talk briefly about the QuotesProxy class, and then we'll talk briefly about the SentimentProxy class. There's some new things here we didn't talk about before. So this particular example shows off 3 models: request response, fire and forget, and request stream. We don't actually do the channel model here just because we don't need to show it. The messages can be sent after we establish the connection with the responder, and that's done through this auto-wired field called a quote requester, which is auto-wired over in the requester beans package. And here's how we set things up. So when you want to subscribe, you'll give the UUID that you're trying to connect to, or for yourself. That's who you are. And then you give the name of the play that you want to get back from the database, if any. And so we set up a route message with the subscribe metadata. We make ourselves a new subscription object that says, I am this client at this UUID. My connection request is pending, and I would like to access this Shakespeare play. And then we go ahead and make this non-blocking two-way call. This is the async request response call to get back a subscription from the responder. And you can see how we use Project Reactor operators to kind of glue all the pieces together. And we cache the results because we don't want to have to do this again if we come along with the same connection. We want to be able to reuse it. OK, now let's talk about the other one. This is the method that we're going to use to get random requests. So you can see here, we want to get back a flux of quotes that correspond to the indices we're going to pass in with the random request. And so we make the metadata to do this. The metadata says, get me the quote subscribed message. And here is the random request. And random request, as you saw before, is just a record that contains a random array of random indices and a subscription that we've validated. So those are the things we need to do this. And remember, the reason we have to make this a random request record is you can only pass one data item to a message in RSocket. So we have to consolidate them inside of a record or a class. Once we've got that, we then do this async two-way call to the responder saying, please get me a flux of quotes that correspond to this subscription and this set of random indices. So that's how we get the data back from that. So we get back a flux of quotes that the caller will then do something with. In particular, it's going to go ahead and ask the sentiment analyzer to figure out the sentiment of these quotes. Speaking of which, here's the SentimentProxy class. This is the last piece of the puzzle on the client side. So getSentiment is the method that we have on the SentimentProxy. It's also got a quote requester, just like the QuotesProxy did. And this also uses a request response, async request response model of interaction. It's also auto-wired. This stuff is the same as before. And then here's the getSentiment message. We give it a string path. And the reason I abstracted this is you could have other sentiment analyzers besides ChatGPT. So, for example, we also have another controller that handles the Stanford Core NLP sentiment analysis, even though it's not as interesting. So we want to make that something that can be abstracted away and parameterized. We go ahead and create ourselves a metadata route message to go into that particular endpoint. We give it the quote we want to send, and then we go and ask the receiver, which in this case is going to be the requester that handles the ChatGPT sentiment analysis, to get us back the updated quote that contains the sentiment analysis. And that contains, we get that back and pass that back to the caller so it can do something like display it. So that's the end of the overview of the client, structure, and functionality.